Okay, today we're going to talk about writing equations. But before we can talk a lot about writing equations, we need to talk about a couple key vocab words. So our first vocab word is a variable. A variable is simply going to be a letter that represents an unknown number. So a letter that represents an unknown number. And it's really important to remember that at the end of the day, we are talking about numbers. Okay? Yes, we use letters like X, Y, A, B, but at the end of the day, each of these is representing a number. So when we use letters as variables, what we're really replacing them with is unknown numbers. It's just a number you don't know. So make sure you do number things with them. And sometimes I'll refer to these as numbers, even though technically they're letters, because I want to emphasize the part that it is that unknown number. It's a number, you just don't know which it is. Okay? There are certain letters that we do not use as variables. The first one I never want to see anybody use is the letter O. And the reason we don't use O is it is way too similar to a 0. So please stay away from letter O. The second one is E. E is actually a decimal, kind of like pi is a decimal. If you want to know what the decimal is, use a calculator and do e to the first power, and it will tell you what that decimal is. But e is a decimal, so please don't ever use it. And the other one we never use is I. And the problem with I is I actually stands in math for an imaginary number. And it ends up being the square root of -1. And you don't have to worry so much about what I stands for right now, but what you need to do is do not use O, E, or I. So you can use any other letter you want, but don't use those. There's other ones that we need to be careful with, but we actually do use them quite a bit. So the first one that you should be careful with is the letter S. And the reason you should be careful with S is it looks a lot like a 5, so make sure if you have 5s with S's that the 5s look clearly like 5s. L's. I always make my L's cursive so that they don't look like 1s. We tend to avoid L's, but they appear a lot in geometry, so that's one that we're allowed to use, but just be careful with them. And anything else that would be similar to this, go ahead and use it. Just be careful that it doesn't look like it. The other one that a lot of people have trouble with is Z's. And a lot of times I actually cross my Z's using the military style just so it doesn't look like a 2. So that's a variable. Remember, a variable is a letter that represents an unknown number. The other two vocab words are expressions and equation. So an expression is, let's switch the color back here. So the difference between an expression and equation is quite simple. An expression has no equal sign. An equation has an equal sign. Other than that, it's just a collection of variables and numbers and operations. So for example, x plus y would be an expression, but x plus y is equal to 3 is an equation. So the only difference between the two is this equal sign. So if we ask for an expression, no equal sign. And if you ask for an equation, there better be an equal sign present. And the other thing I want to talk to you about briefly is making sure that you read the question, because a lot of times people have trouble with these because they're not reading the directions on what to do. All right, so let's start looking through an example problem. Here's our first example problem. This says a farmer's market sells apples for $1.50 per pound and grapes for $1.75 per pound. Write an expression. That is a mistake up there. I'm going to go fix it right now. Should say write an expression to represent the total amount of that the farmer's market can earn selling apples and oranges, or apples and grapes. Okay, so we're selling apples and grapes, and we want to know how much they earned. Okay, so the first thing we should do is we should highlight the key important information. So the first thing I'm going to highlight is apples, and we are selling apples for $1.50 a pound. The other important information is how much we sell grapes for, and grapes are sold for $1.75 per pound. So that's the information I'm going to be using to write my expression. The next thing I want to do is highlight the important details of what I am supposed to do. So the directions say I'm supposed to write an expression. So I know that I'm going to be writing something without an equal sign, but I could write any couple letters here and put them together and have an expression. So what specific expression do I need? Well, I want an expression that's talking about the total amount that a market can earn. And what are we selling? Apples and grapes. Okay, so that's what my expression needs to do. So now that I have the important information, the first thing I need to do is define my variables. You can't use letters or any other variables until you first let us know what it is that they represent. Okay, so in this thing, my first thing I'm going to use is A for apples. And A is going to represent the number of pounds of apples. So if I say that A is 1, that means I have 1 pound of apples. If I say A is 2, that means I have 2 pounds of apples. So A is representing the number of pounds of apples that I have. And I'm going to use G for grapes, and that's going to represent the number of pounds of grapes I have. And it's really important to make sure that you go through this step, because if you don't do this step, I could have defined this A to be anything or G to be anything. Maybe I define A to be number of individual apples, and G could be the number of bunches of grapes. And I want to make sure that I know exactly what A and G is. So in my case, A is not the number of apples, but the pounds of apples. And G is not just the number of grapes, but the pounds of grapes. So make sure you define them very well. All right, so now the next thing I got to do is I'm going to go ahead and write an expression. Okay, so my first guess is that I'm going to say, hey, I know I have pounds of apples and I have pounds of grapes, and I need a total, so I'm going to add them up. The problem with this is what it's telling you is that this is just the total amount of fruit that I have bought in pounds. So if I say had 3 pounds of apples and 4 pounds of grapes, I have bought 7 pounds of food. But that didn't answer the question up here. The question up here is, how much did we earn? So this is a valid expression. Unfortunately, it's just not the expression that was asked for. But keep this in mind, because it is a valid expression. It's one that we do use quite a bit. So this would tell us how many pounds of fruit that we had. Unfortunately, what I need to know is apples, or earned. So let's look at the apples first. Let's say that I have 1 apple, and I want to know how much it costs, and that is $1.50. And if I have 2 pounds of apples, then I have spent $3. And I want to know how much 10 pounds is worth. Well, the way we ended up doing this is we could have added $1.50 each time, or I could have said I'm going to take that 1 pound of apples, I'm going to multiply it by $1.50. And I could take the 2 pounds of apples and multiply it $1.50. So if I take A and multiply it by $1.50, I should get the total amount, and we're going to write that as $1.50 A. So if I want to know how much 10 is worth, we do 10 times $1.50, which ends up being $15. So this expression right here, $1.50 A, represents the amount of money we have earned, or we've sold our pounds of apples for. So our pounds of apples are going to be $1.50 A. And for the same reason, we can do the same thing with grapes. So our grapes are going to be $1.75 G. So this is how much we have earned from our apples, and this is how much we have earned from our grapes. Now it says that I need the total amount, and when we want the total amount, we simply want to add them up. So we're going to put a plus inside. So here's our expression right here that represents the total amount that the farmers earned selling apples and oranges. It's $1.50 times A for apples plus $1.75 G, meaning grapes. Okay. Another important thing to recognize is if I switch A and G, then this expression is no longer valid. So it's really important to make sure that these are defined, and you have to, if you don't define them, then this expression doesn't have much meaning. So a lot of people don't like doing this, but without this top section here where you define your variables, the expression you write has almost no meaning. Because if we get rid of this completely, then I don't know if you're right or wrong. Okay, so let's say that this isn't here. This is what I typically see on work. It just says $1.50 A plus $1.75 G. I may assume that you mean apples and grapes, but maybe you mean something completely different. So if you don't tell me what A or G are, I can't tell you if this is right or not, even though it very well looks like it probably is right. So make sure you define your variables. So what is A? What is G? In this case, it was pounds of apples and pounds of grapes. All right, let's look at the next example. On the next example, Sarah is selling chocolate bars for fundraisers. She has milk chocolate bars for $1 and dark chocolate bars a little bit better, so they're selling for $1.25. Sarah wants to earn $200 from this fundraiser. So we're going to write an equation for the total amount of money she earned. So let's do what we did before, and we're going to highlight the important information. So the important information here is that milk chocolate bars are costing $1, and dark chocolate bars are going to cost $1.25. Okay, so that's our important information. And one other piece of important information is that she wants to earn $200. That's her goal, is to earn $200. So what is our task? Well, our task is right here. We need to write an equation for the total amount of money Sarah earns. Okay, so we're talking about money, we're talking about earning, and we need the total. So let's start with the expression, and then we'll talk about the equation. So the expression that we would have written is just like it was in the last example, is we have milk chocolate bars that are selling for $1. And from first off, we have to define a variable. So let's use M for milk chocolate bars. And this is going to be individual bars. And we're going to use D for dark chocolate. And again, we're just counting bars. So this is an individual dark chocolate bar. So M is milk chocolate bars. D is number of dark chocolate bars. Go ahead and put the number symbol here. So number of milk chocolate, number of dark chocolate. Okay, so if I want to know how much money I've made from milk chocolate bars, I want to do $1 times M. This would be the total amount of money from our milk chocolate bars. And similarly, the dark chocolate bars are going to be $1.25 times D. So if I want the total, I am, of course, supposed to add it up. And this would have been the expression from our first example. Now, what's different here is now I have this extra information about how much it earns. Well, this is a fancy way in math of just saying this is our total. So if I add these up and I put an equal sign here, I would get the total, but it wouldn't just say total. I actually know what this is. So instead of writing total, we're going to put the total that we know. And in this case, we want the total to be $200. Okay, now I'm not going to require you put the dollar symbols here. If you want to put it here, it should also be here and here, or you can leave it off. So our equation that we want for the total amount of money earned is going to be $1 times M plus $1.25 times D is equal to 200, where M is talking about the number of milk chocolate bars and D is talking about the number of dark chocolate bars. Now, to be a correct answer, all of this information needs to be present, so please do not forget that. All right, let's look at another example. So in this example, it says Joe is an artist. In his studio, he sells prints for $49. Unfortunately, Joe typically has 3 prints ruined each month. Write an equation for Joe's total profit each month. Okay, so just like in our first 2 examples, let's look at the key important information. The first thing that I see is that he's selling prints for $49. Okay, but there's a problem, and the problem is that there are 3 prints ruined each month. Okay, so we're going to have to account for that. And then let's look at the directions, and our directions say that we're supposed to be writing an equation, so I know I need an equal sign, and it's supposed to represent the total profit each month. So that's what I need to be doing. So first thing, I'm going to need to define a variable, and I'm going to use prints, and this is going to be our P, and we'll use that to talk about prints. And this is going to be number of prints. So we're just going to count them. So number of prints. And the other thing I'm supposed to have is the profit, because that's the other thing I'm looking for is what's this total? Well, I can't use P because I've already used it. It means prints. So we're going to use D. And the reason I picked D is for dollars. But D is going to represent our profit. Okay? And if you don't want to use D here and you want to use P here, then pick something other for P for prints. But you can only use the letter once. Okay, so let's take a look. I want the profit. Well, what do we know? We know that prints are going to be $49. Okay, and if I multiply it by P, this is the amount of money I've made from my prints. And generally speaking, that would be my total. However, remember we had this problem that we're losing 3 prints each year, or each month. Now, there's a couple ways to do this. The first way, and this is the incorrect way, but I'm going to show you anyways, that I see a lot of people do it, is just to say minus 3. Now, here's the problem with this. So this is not correct, but here's the problem. 49p is representing money. Our profit is representing money, but this 3 is not representing money. What the 3 is representing is the number of prints. So if I take money and I subtract away a number, I should never get money again because these are different types of things. So we need to translate 3 into money. And here's how we're going to do it. So we got to go back and fix this. So it's not going to be 3 right here. What we're going to do is instead we're going to talk about how much money we have lost. Okay, so first it's going to be a subtraction problem because we're losing. And how much was 3 prints? Well, 3 prints is going to be 3 times that $49. Because remember, 1 print's $49, so we want 3 times that. And if I take 3 times $49, that would end up being money. And money take away money is indeed more money. Now, it's fine the way it is, but because we're mathematicians and we don't like to leave things that we know, we can actually clarify this a little bit, and we'll actually do this multiplication out. So the best answer would be 49p minus, now, a little trick here is instead of doing 3 times 49, I'm going to do 3 times 50. And then I'm going to subtract off 3 from that answer because this is really 49. 50 times 3 is 150. Take away that 3 because I lost $1 3 times is going to be $147. So this is costing $147, and our total is going to be D, and this is our equation. Okay? Now, there's another way you could have written it, and it's a perfectly valid way, and that is to say that how many prints that he's selling starts with P, but he loses 3 every month. So this is now the number of prints that Joe has at the end of the month, and when I multiply the number that he has at the end of the month, which is P minus 3 times 49, now I have profit. Okay, so this would equal D. And this is an equally valid solution. So here's solution number 2. And the reason these are the same is because of the distributive property. So this is a property you should have learned before. The distributive property says if I take something outside with a set of parentheses that I can multiply from outside to inside. So the way we would do this is you would do 49 times P. And when you do that, you get 49P, which is what we have right here. And then we do 49 times negative 3. Well, 49 times negative 3 is right here at negative 47. So indeed, these two equations are what we call equivalent, which means that they are the same. Okay, so here's 2 different ways to write the same equation. One with parentheses, 49 parentheses P minus 3 is equal to D. And the other one without is 49P minus 147 is equal to D. Either one is correct, and you should be able to write either equation. So this is an example when something is being lost. You could do the same thing if you add something instead of losing it. Maybe Joe typically has 3 prints additionally donated to him, so then we could add 3. But more typically is something gets removed in a real life scenario. So if you have any questions, please make sure you ask. Like anything else, you need to really do a lot of thinking on these, and when you do a lot of thinking and you practice, you will get much better at this. So make sure you practice, and if you have questions, please ask for help.